Welcome back, my dear students. So in this session we do some more problems using the principle of mathematical induction. Okay, so the problem is prove by induction that 2 to the power of n is greater than n for all n belongs to n. So prove by induction means prove by mathematical induction. Okay, so we have to prove that 2 to the power of n is greater than n for all n belongs to n. Capital letter n means set of all natural numbers. So we have to prove that 2 to the power of n is greater than n using the principle of mathematical induction. So we have to follow the same procedure. Okay, what is the first one? We have to take the given statement. Here the statement is 2 power n is greater than n. So consider this as p of n. Okay, so the solution is, let p of n is what? 2 to the power of n is greater than n. So what is the step 1? First step, that is step 1 is what? Prove that p of 1 is true, right? So the first step is we have to show that p of 1 is equal to p of 1 is true, right? So that means when n is equal to 1, so p of 1 becomes what? P of 1 becomes 2 power, here we have 2 power n. When n is equal to 1, so it becomes 2 power 1, which is greater than. So n means what? 1. So this is nothing but 2 power 1 means 2 is greater than 1. Obviously, right? 2 is always greater than 1, which is true. Which is true, right? So therefore, p of 1 is true. Understand? So the first step is we have to show that p of 1 is true, right? So for that, put n is equal to 1 in p of n. So it becomes p of 1 is equal to what? Here we have 2 power n. When n is equal to 1, it becomes 2 power 1 is greater than n means is greater than 1. So which is nothing but 2 power 1 means 2 is greater than 1, right? So 2 is always greater than 1. So which is true. Therefore, p of 1 is true. So the step 1 is completed. So we move on to step 2. Step 2. Step 2 is what? Assume that p of k is true. So we have to, the step 2 is we have to assume that p of k is true. Okay, that is, if p of k is true, then what is the statement becomes? P of k is equal to what? Or p of k is true means 2 to the power of k is greater than k. This is p of k, right? So the first step is we have to show that p of 1 is true. The second step is we have to assume that the given statement is true for some k. Okay, that is 2 power k is greater than k. So this is step 2. And come to step 3. So step 3 is what? Prove that p of k plus 1 is true. So we have to show that the given statement is true for k plus 1th term. Okay, that is, so which means what? We have to show that is 2 power k plus 1 means put k is equal to k plus 1. P of k plus 1 is greater than k plus 1. So we have to prove this condition. P of k plus 1 is greater than k plus 1. Okay. So first call this equation, this statement as equation 1. So we have to show that what? P of k plus 1 is true. We have to prove that. So that is, we have to show that p of k plus 1 is greater than k plus 1. So how to prove this step? So for that, from step 1, from equation 1, from step 2 or from equation 1, so what we have? We have 2 to the power of k is greater than k, right? This is our step 2, or I call this equation as equation 1. So 2 power k is greater than k. We already assumed this. This is true. So I consider from 1 we have 2 power k is greater than k, and also 2 to the power of k is greater than Okay. So therefore P of k plus 1 is also true, right? Understand? In the step 3 we have to show that P of k plus 1 is true. That is, we have to prove this condition. For that I consider step 2 and also I write this condition. 2 power k is greater than 1. Then I have these two inequalities. Then I get 2 power k plus 1 is greater than k plus 1. So which is nothing but our P of k plus 1. So therefore P of k plus 1 is also true. So all the three conditions are satisfied, right? Hence by the principle of what? By the principle of mathematical induction, the given result is true for all natural numbers. Understand? So if all the three conditions are satisfied, hence by the principle of mathematical induction, the given result, that is 2 power n is greater than n, is true for all natural numbers. Understand? So we move on to the next problem. So the next problem is prove by induction. The next problem is prove by induction, that is mathematical induction, that n into n plus 1 into 2n plus 1 is divisible by 6. So this problem is quite different. So what is the problem? Prove by induction, that is prove by mathematical induction, that n into n plus 1 into 2n plus 1 is divisible by 6. So we have to show that this number is divisible by 6 by the principle, using the principle of mathematical induction. Okay. So follow the same procedure. First, take the given condition or statement as P of n. Let P of n is what? N into n plus 1 into 2n plus 1. Okay. So what is the first step? Step 1. Step 1 is prove that P of 1 is, so which is not true. So we have to show that P of 1. So we have to show that what? This is divisible by 6. So in the first step we have to prove this is true for n is equal to 1. That is, we have to show that P of 1 is divisible by 6. P of 1 is divisible by 6. So idana now prove maadu. P of 1 n is equal to 1 kottaga the given statement or the given result divisible by 6 agutte anta we have to prove that. Okay. So P of 1 is divisible by 6. We have to show that. So that is when n is equal to 1. So this becomes P of 1. So put n is equal to 1. So 1 plus 1, 2 into 1, that is 2 plus 1. So which is nothing but 1 into 1 plus 1 is 2 into 2 plus 1 is 3. So 1 2s are 2, 2 3s are 6. So P of 1. So 6 means always it is divisible by 6, right? 6 is divisible by 6. Divisible by 6. So what? P of 1 is divisible by 6 we get. So which is true. Which is true. So therefore P of 1 is divisible. Divisible by what? 6. The first step is completed. I will explain once again. So we have to show that this number is divisible by 6. We have to show that condition. So for that I consider the given statement as P of n. So using the principle of mathematical induction, the first step is we have to show that the given statement is true for n is equal to 1. So which means we have to prove that P of 1 is divisible by 6, right? So when put n is equal to 1, you will get P of 1 is 6. So 6 is always divisible by 6, right? So which is divisible by 6. So which is true, right? So P of 1 is divisible by 6. So the step 1 is completed. What is step 2? Step 2. of k is divisible by 6. So in the step 2 we have to assume that the given statement or p of k is divisible by 6. So here this is we assuming this statement, that is what, p of k is equal to what, k into k plus 1 into 2k plus 1 is divisible by 6. We assume this condition. So if it is divisible by 6, which is nothing but some 6 into k, where k belongs to some integer or some natural numbers. Okay. So ಇದನ್ನ ನಾವೇ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊತಾ ಇರೋದು. ಏನಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ p of k is divisible by 6 ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊತಾ ಇದೀವಿ. Divisible by 6 means it's some multiples of 6. For example, 6 is divisible by 6, right? So next to 12, divisible by 6, right? So this 12 can be written as 6 twos are. So all multiples of 6 are divisible by 6. So next to 18. So 6 threes are. So it's a multiple of 6. Okay. So multiples of 6 is always divisible by 6. Okay. So this is I assume in step 2. When come to step 3, step 3 is what? We have to prove that p of k plus 1 is also divisible by 6, right? In the first step we prove that p of 1 is divisible by 6. In the step 2 we assume that p of k is also divisible by 6. In the third step we have to show that p of k plus 1 is divisible by what? 6. Okay, that is, so we have to get that p of k plus 1 is equal to, put k is equal to k plus 1. So k means k plus 1, k plus 1 means k plus 2, 2k plus 1. So 2 into k plus 1 plus 1. So 2k plus 2 plus 1. So which is nothing but 2k plus 3 is divisible by 6 ಅಂತ ನಾವು ಪ್ರೂವ್ ಮಾಡಬೇಕು. p of k plus 1 is this. So this number is divisible by 6 ಅಂತ we have to show that. Okay. So how to prove this? So to prove this step 3, consider the step 2, p of k as equation 1. Consider this as equation 1 and consider p of k as equation 2. So to prove this condition, equation 2 minus equation 1. So we have to subtract equation 2 by equation 1. So it is nothing but in LHS we have p of k plus 1 minus 1. Equation 1 is this. So in LHS we have p of k is equal to, when come to RHS, 2 minus 1, first write equation 2, RHS of equation 2, that is k plus 1 into k plus 2 into 2k plus 3 minus equation 1, RHS of this one. So that is k into minus k into k plus 1 into 2k plus 1, right? So I subtract equation 2 by 1. Okay, 2 minus 1 means this is the LHS of equation 2 and 1. This is the RHS of equation 2 and 1. p of k minus k plus 1 minus p of k is equal to, then write this one minus this one. Okay. So next, here what is the common term? K plus 1 is the common factor. So take k plus 1 is the common factor. Then the remaining terms are k plus 2, 2k plus 3 minus. So k plus 1 common, that the remaining k into 2k plus 1. Right, now simplify this one. K plus 1 multiply ಮಾಡಿ k into 2k, that is 2k square plus k into 3, 3k. I multiply this k with these two terms. K into 2k means k into k, k square, 2k square. Okay, plus k into 3 means 3k plus 2 into 2k means 4k plus 2 3s are 6 minus. So multiply this term also. K into 2k means 2k square. Minus into plus minus k into 1 is k. Okay. Then 2k square minus 2k square gets cancelled. So the remaining terms are k plus 1 into. So add all the similar terms. is also divisible. Is also divisible by what? Divisible by 6. Understand? So if you simplify, you will get P of k plus 1 is equal to 6 into some number. That is multiple of 6. It is nothing but multiples of 6. So multiples of 6 is divisible by 6, right? So therefore P of k plus 1 is also divisible by 6. So all the three conditions are satisfied, right? Hence by the principle of mathematical induction, the given result is true for all natural numbers. So you have to write at the end, you must write this line at the end. Okay, so this is the procedure to find the given number is divisible by 6 or not using the principle of mathematical induction. Okay, so the problems, the continuation of this type of problems I will